Okay, so draw the output voltage waveform for each circuit in the figure with respect to the input. Show the voltage levels. Okay, what type of amplifier circuit do we have here? We have here an open loop amplifier, okay, which means that the gain is determined by its open loop gain. Okay, there's no feedback circuit. This means that whatever input we put in, the output is determined by the open loop gain, which is typically hundreds of thousands. And the maximum voltage here, at least in the first figure, is 8 plus or minus 8 volts, and for the second figure, it's plus or minus 10 volts. So even if you have an output or a gain of hundreds of thousands, you cannot, but from conservation of energy, naturally you cannot provide an output that is greater than what you feed into the amplifier. Okay, so if the input is 1 volt or 2 volts, then the output is will give you a maximum of plus or minus 8 volts. Okay, now let's take a look at the first figure, figure A, figure 60A. And we first notice that the ground is actually connected to the non-inverting input. Okay, in the examples that we discussed in the lessons and in the examples that you will probably read in the book, the comparator, okay, is actually the reference is actually placed in the non-inverting input, but here we have a reference that is placed that is the reference is placed in the inverting input, but here we have a reference that is placed in the non-inverting input. So what is the consequence here? So like we said, regardless of what the difference in voltage here is between these two terminals, okay, regardless what the difference of these two voltages there, it will give an output of maximum plus or minus 8 volts. So, but since we have an input that is negative, which is lower than the ground, it means that the output will be the negative of the input. Okay, so which means that here our trigger or our reference is ground, so our trigger is at 0 volts. So every time the signal crosses the 0 volt line, it will produce an output. Okay, in this case, the output is plus or minus 8 volts. So if this is 1 volt, then probably 8 volts is around this large. Okay, so again, once it crosses the trigger or the 0 volt, it triggers the output to switch signs. Okay, and then you have that. Okay, so that's your output voltage for this type of circuit. Okay, in the second circuit, comparator circuit, we have a reference, okay, that is plus 1 volt, which means that every time the signal crosses the positive 1 volt line, the comparator triggers the switch of the signal from positive to negative and vice versa. Okay, so we have the input connected to the non-inverting terminal. Okay, so let's just draw here the plus 1 volt line. So that's the plus 1 volt line. Okay, and let me just change color just to avoid confusion. So the thing is that it changes direction whenever it crosses the 1 volt line. So initially it's like this, so it's about 10 volts. So 10 volts could be something like this, maybe. Okay, and that's also the 10 volts right there. Okay, and then once it crosses the positive 1 voltage line, triggers like this. Okay, and that. Okay, so that's how this output looks like according to the comparator circuit here.